we have one more rule. And with this last rule, we will have the capabilities of finding the tangent slope generator to practically any type of function. Okay? The type of function we need to deal with are the following. Functions that are being composed. Notice, I have what I consider like an outside function and an inside. Inside and the outside. I have what I consider kind of like an outside function, the square root, and an inside function. This one I probably could distribute right away, but just showing you the similarity. This is a composition of an outside and an inside. Okay? Now, if I asked you to find the tangent slope generator of these three, you could do J by distributing, but you need a new rule to deal with these compositions. Okay? The rule to deal with them is called the chain rule. When you have a composition of functions, that means you have an outside function and you got an inside function. This is not a product. F of g of x is a composition, not a product. You're asked to take the derivative of this composition. Now, it's very important for you guys to know that this derivative rule just doesn't come out of nowhere. It comes from this formula, our magic tangent slope generating formula. We'll, I guess, mostly consider this a magic tangent slope generating rule formula. And this is what we're going to do. We're going to identify the outside, identify the inside. We got f of, we got g of x. We will take the derivative of both of those pieces that are being composed. The derivative of the outside, I'm just going to say, is f prime of stuff. The derivative of the inside is going to be g prime of x. If we take a product of the derivatives of those two composed functions, that, my friends, is the chain rule. So I will write the derivative of f of g of x as f prime, we're going to leave that stuff blank for now, times g prime. Now, we're not going to leave blank space. When we take the derivative of the outside, we're just going to leave the inside alone. So whatever started inside this f, I'm going to end up in the derivative of f. So g of x is going to go right here. Okay? Now, just to show you this works, I'm going to go back to this first example, and I'm actually going to distribute to take the derivative. You don't have to do this. I'm just going to show you so you can see. So j of x simplified would be 4x to the fourth plus 12x squared plus 9, because I know how to square things. I don't just square the first plus the second squared. This is 2x squared plus 3 times 2x squared plus 3. So its derivative, using just the power rule, is 16x cubed plus 24x. Cool? Great. Watch how I can get 16x cubed plus 24x using this new rule, the chain rule. The outside, like I said above, is the square. The inside is the 2x squared plus 3. We will go ahead and take the derivatives of those two composed functions and multiply them together. Now, what's the derivative of parentheses squared? Why don't you just think about it and like take a guess with your neighbor? What do you think the derivative of parentheses squared we want to be? If you think an x squared, its derivative is 2x to the first. I would say this derivative is 2 times stuff. The derivative of the inside, that's easy, 4x. Well, if I take a product of those two derivatives of the composed functions, I get 2 parentheses times 4x. Don't leave just blank stuff. It's whatever started out in the outside. So the 2x squared plus 3 started in the square. The 2x squared plus 3 ends up back in here. 2x squared plus 3 will go in there. I will show you how this is the exact same derivative as what I got before, just by simplifying the 4x times the 2 and then distributing the 8x. 16x cubed plus 24x. The exact same as what I got above distributing. Yeah.
So for this method, you don't have to do the product rule to just multiply it?
So it's not a product here. Question is like, do we not have to do the product rule? Like, we took the derivative using this process, we got this. This is the tangent slope generator. All I did after that was simplify. Now we will find that for this, yeah, it was pretty easy to simplify, it will. For the other ones, it will not be easy to simplify, and we will not want to do that. Take h especially. You do not want to simplify the derivative of h, but let's see if we can find what the derivative is. Note what the outside and the inside are. Probably write small because this is going to be kind of long. The outside, in this case, is the parentheses to the 5th power. The inside, 4x cubed minus 3x squared plus 2x. Take the derivative, multiply them together. Now, the derivative of parentheses to the 5th is not just 5 parentheses. Don't forget the power rule. It'd be 5 parentheses to the 4th. Inside 12x squared minus 6x plus 2. Our derivative, our tangent slope generator, though it is long and though it is pretty crazy, this is correct. If you plug in x coordinates into this function, you will get tangent slopes to h. It's like fascinating how it's like that easy to get a tangent slope generator to a seemingly extremely complicated function. I'm going to have to write smaller. 5 parentheses to the 4th. Inside is the 4x cubed minus 3x squared plus 2x. This went in there, or this stayed inside the derivative of the outside. Okay, let's do k. In this situation, the root is the outside, but we don't use like the root rule. We rewrite a square root as a 1/2 power. So same deal, parentheses to the 1/2 would be the outside. So 1/2 stuff to the negative 1/2 times 20x cubed. What is the stuff? 5x to the fourth plus 3. Now, please notice, sometimes when I walk around, I see this. If you have a sum or a difference or anything inside your derivative of the inside piece, make sure this is all in parentheses. That way, if you wanted to, say, simplify with this 5, well, that 5 would have to be distributed into the 12x squared minus 6x plus 2. It can't be distributed into the stuff to the fourth power because of order of operations. We'd have to take the power first, then multiply by the 5. But I can distribute the 5 in there. But it has to be in parentheses. This is not as important because we don't have an addition or a subtraction of something. So I don't need to have parentheses here. However, it is important to realize that we have a product of 3 things. 1/2 times this times this. You know, what is it? The commutative property of multiplication says I can multiply any of these in any order. I can take this 1/2 and multiply it by the 20x cubed. It is very easy to simplify this. You would be expected to know how to simplify this. 1/2 times the 20x cubed gives me 10x cubed. In the denominator, I can write the 5x to the fourth plus 3 rooted. Okay. Great. Next 2. Just quick practice. You guys do them. I'll do them. You look up on the board to see if you got them right. These are the easy ones, though. So, like, we should be able to comfortably find the tangent slope generators for these 2 y equals right now. And then we'll have to work on the tougher ones. I simplified the one on the left, but I really didn't have to, wouldn't in the future, because it is in like a factored form. This product rule, this chain rule ends up putting things typically in a factored form, which is nice, but just showing you if you were trying to incorporate this 3 into something, you could multiply and distribute the 3 into the 6x and the minus 2. The one on the right, though, I didn't, because it's not necessary either way, just showing you what you could do. Okay? Not bad, right? Hopefully we don't feel like this is very intimidating, because it shouldn't be. As long as we can identify outsides and insides, multiply the derivatives of those composed functions, and we're fine. Okay? Where things get tricky, though, which you need to be intimidated about, which you need to be scared about, are the following. Especially this guy on the left. Everybody messes up on the guy on the left because we're just working on the chain rule. We understand the composition, and people immediately go to the O's and the I's, and they say the O is x squared, parentheses to the fourth, and the I is 2x cubed minus 3. But they shouldn't. Okay? You would end up making an error, especially when you take the derivative of this. And actually, it doesn't work out if you do this. Because your error is that this is a product. X squared times our stuff to the fourth power. And because this is a product, you must use the product rule first. And it's when you are using the product rule that the derivative of the second piece, you need to use the chain rule. Okay, so we are using two rules kind of all together at once. Let's see what this looks like. Derivative of the first times the second plus the derivative of the second. Okay, now that I'm talking about the second's derivative, I need my O's and my I's. My O is stuff to the fourth. My I is 2x cubed minus 3. Derivative of my O, derivative of my I, multiply them together. You should be able to do that. This is an easy one. Now, another place where students mess up with these problems involving multiple rules is they forget to multiply by the first. Don't forget the product rule. Derivative of the first times the second plus the derivative of the second times the first. So don't forget the times the first. Now, this is something that I can simplify pretty easily on the right side. I can multiply, since this is multiplication, this times this times this times this, I can multiply these three together to get 24x to the fourth times 2x cubed minus 3 cubed. However, there is more simplification that I can do that I'm actually going to be expected to do. You will be expected to do this on the quiz. I will tell you, simplify fully to get what ends up being a product. And on your homework, I'll ask you to simplify things fully. Because you'll see a test question like this, where you're going to get this as your change in slope generator, and you are not going to see that choice in the multiple choice answer selections. So you need to know how to simplify this more. And what we are going to do is we are going to factor. I will factor out what these two terms have in common. Look and discuss with your neighbors. What do they have in common, and what can I factor out? If you notice that you not only can pull out a 2x, but you could also pull out 3 of these 2x cubed minus 3s, you are on top of this. So that's getting factored out. I'm going to put it over here. The stuff that is left over ends up in here, separated by addition. Now, from my first term, I just have 1 2x cubed minus 3 left over. The 2x is gone, and 3 of these are gone, so just 1 2x cubed minus 3. From the second, all of the 2x cubed minus 3s are gone. I get 2x out of 24x to the fourth. That's going to be 12x cubed. Notice, I have 2x cubes and 12x cubes. I can add those. This is the form I would expect you to be able to get to. You will practice getting here on your homework because you're doing it on your quiz and you're doing it on your test. Okay, so that was one way that multiple rules kind of pop up. Is product rule first, chain rule within inside the product rule. The second one, we have a chain first, but we have a quotient inside the chain. What do I mean by that? For the second one, I am thinking of my O's and I's right off the bat. My stuff cubed is the outside, but it's the inside that is a quotient. And when I take the derivative of the inside, I must use the quotient rule. Let's see if we can do that. Derivative of the top times the bottom minus the derivative of the bottom times the top. All over the bottom squared. Probably should simplify the numerator. X minus 1 minus x. That just turns into negative 1. Derivative of the outside, leave the inside alone, times the derivative of the inside. Okay, great. This is correct. This is fine. However, you will be expected to simplify this further. How? Well, I'm going to square the stuff inside parentheses. Remembering, when you square things inside of parentheses, if they're separated by multiplication or if they're separated by division, you would square the top and the bottom. I'm not going to write the x minus 1 squared out. I'm not going to distribute the x minus 1s because I notice right here that these x minus 1s are being squared. I can multiply by these x minus 1s. I get 4x minus 1s in my denominator. In my numerator, I have negative 3x squared. You will be expected to get here. Okay, so chain rule, not intimidating, but functions that involve multiple rules, yeah, should be a little bit intimidating. You'll need to practice. Now, all of them that we used so far all had like parentheses to a power. We all use the power rule for the derivatives of all of these. We will see that that's not always the case. The first one, if I rewrote, and we need to be comfortable rewriting sine squared of x as sine x squared, still, the outside is the square, the inside is the sine. But we will find in some situations a trig function will be the outside. If you see something sine x squared like this, you probably can rewrite it, not probably, you should rewrite it as a sine and use parentheses of x squared. In this situation, the outer function is a trig function. It is not a parentheses to a power. And that's okay. The inside is x squared, and that's okay. The chain rule still applies. You're still going to take the derivative of the outside and the inside. You're going to multiply them together. Go ahead and do that for both of these situations. Write out the y prime for sine squared x and sine of x squared. Okay? 2 sine x cos x, cos of x squared times 2x. It's pretty fascinating that these two functions, like, we can just get like that. Okay? We can get the tangent slope generator just like that. Okay. Can I multiply the x squared and the 2x to make it 2x cubed, cos 2x cubed? No, don't do it. Okay? The x squared's inside the cosine. Order of operations, I got to do that trig function first before I worry about the multiplication. So don't do that. We're done. This is perfect. Move on. Making sure you understand outsides and insides. It is helpful to rewrite whenever you see trig functions. I would rewrite this as tan x cubed. This is already written out for me. Secant of x to the 5th. Here the outside is a parentheses to a power. Here the outside is a trig function. Let's just write down the outsides and the insides. And we'll talk about the derivative of the one on the right in a second. Guy on the left. That guy. What's the derivative of secant? Parentheses. Take a guess with your neighbors. Let's see if you can remember. Challenge your neighbor. Do you remember the derivative of secant? And what is the derivative of secant parentheses? Positive or negative, right? I don't know. What I like to hear is people saying the derivative of secant x is secant x tangent x. So the derivative of secant parentheses would be secant parentheses tangent parentheses. I see students write, oh, derivative of secant, secant tangent, but you forget that you need secant x tangent x. So watch what happens here. When I take the derivative and have the product of these two, I get secant stuff, tangent stuff, times 5x to the 4th. I need to take the x to the 5th and put it in 2 locations, here and here. So some people do secant x, tangent x to the 5th, or secant x to the 5th, tangent of 5x to the 4th or something. So you just got to be comfortable doing it this way to get this. Okay? Okay, so that's a little tricky. We got rules within rules. We got trig functions that can be kind of funky. Don't worry. They get a little bit more complicated. Please rewrite sine cubed 4t squared using parentheses. So get rid of that sine cubed and rewrite it using parentheses. This is an important part of the process. Sine of 4t squared all being cubed is what you should write. I'll show you 2 ways to handle this. The second way is what I would recommend you use. First way, I would not recommend you use it. The first way to handle it is to think O's and I's. Okay, the outside is the cubed, the inside is sine of 4t squared. But actually with that, that's got an O and I. That's got a sine as an outside and inside of 4t squared. So I wouldn't recommend you do that. Instead, I would introduce to you an M. Outside, a middle, and an inside. We are composing three functions here. It's cubed, it's sine of stuff, and it's 4t squared. See, I told you they got trickier. The chain rule still is the same. We take the product of our composed functions. So I'm going to write out all the derivatives. 3 stuff squared. Cosine stuff 8t. And I'm going to think about multiplying these three together. And as long as we can identify outside, middle, and inside, we shouldn't have a problem, at least with this part of it. But some people have the problem with what goes inside the parentheses. Discuss with your neighbors. See if you have an idea of what goes inside each set of parentheses. What goes inside this? What goes inside this? Let's take a guess and see if you're right. Sometimes it's easier to work like outside in or vice versa. 4t squared goes in there. The 4t squared plugged into the sine goes in there. Think about like what started in the cubed. What started in the cubed is the sine of 4t squared, sine of 4t squared. What started in the sine? 4t squared, 4t squared. All right, let's try this one. Why do I have the 1/4 there? I don't know. Maybe to confuse you. Let's see. Step one is to write things out using parentheses so you really truly understand the outside, the middles, and the inside. All of our original ones that we did, our first examples, one set of parentheses, two composed functions. This previous one I did, two sets of parentheses, three composed functions. How many sets of parentheses are here? 3. How many functions are being composed? 4. We got an outside. I'll put the 1/4, which is just a constant, in with the squared. That's our outside. We got a middle. Sine. We got another middle. Stuff to the 5th power. We got an inside. 3x plus 2. We're going to need some space. If you can identify those, the rest should kind of fall into place so long as you keep track of what goes in what. Take the derivative of all those pieces, and we will multiply them together. Here we go. Group. F prime is 1/2 cosine 5 to the 4th, 3. 1/2 to 5 and 3 can be multiplied. That's 15/2. So, boom, 15/2. All right. What goes in here? The sine of 3x plus 2 to the 5th. What goes inside the cosine? The 3x plus 2 to the 5th. What goes into the 5 to the 4th? The 3x plus 2. Finish off with the 3. I already did the 5 times the 3. That's just like an overkill example. For a test or a quiz, the most you will be expected to take the derivative of in terms of compositions are 3 composed functions. You will be expected to take the derivative of an outside, a middle, and in. I don't think I've ever seen a composition of 4 things on a test. Okay? Moving on. This is just another type of problem designed to sometimes confuse students because of like rules inside of rules. Now, if I ask you to find the second derivative, first derivative should be no problem, outside, inside, using the chain rule. You actually could write this as sin x, and use the product rule. But for some reason, when I ask you to take the derivative twice, and you get here, and you go to the second derivative, you forget you got to use the product rule now. So leave the 2 out, multiply by the derivative of sine x times cos x. Derivative of sine x times the second cos x plus the derivative of cos x, which is the second, times the first. You might think there is some sort of trig identity to simplify this, but there's not. Getting to the problems that we were introduced to last class, these table problems, where you're not given specific functions, instead just like f's and g's. What is very, very important is to understand that this is not a product. You are not using the product rule. You have an outside, you have an inside. Write down what the outside is and the inside. Take the derivatives. Multiply those composed derivatives. Okay, so I got f prime of g of x times g prime of x, f prime of x. But we're not done. These table problems, we want a numerical answer. We got x equals 2 that we want to evaluate these at. So we are going to plug in 2. This becomes f prime of g of 2 times g prime of 2. It's very important not to think this is f prime of 2. This is f prime of g of 2. To be able to find this, you need to work inside out. G of 2 is 3. So this is f prime of 3. G prime of 2 is negative 2. That's great. But I need to go to f prime of 3. That's 4. Multiply that by negative 2. My answer is negative 8. Okay, do the one on the right. See if you can evaluate this one on the right. G prime of f of x times f prime of x when x is 2. I get 12. F of 2 is negative 3. G prime of negative 3 is 2. Cool? Okay. Same thing goes with given graphs. This one we just kind of did, so I'm just going to quickly write down the derivative f prime of g times g prime of x. Now let's look at 1. Okay, don't find f prime of 1, find f prime of g of 1. G of 1, if this is 1, is 2, 3, 4. This is g of 1 at 4. G prime of 1 is the slope of g at 1. This slope looks like it's negative a half. F prime of 4, the slope of f at 4 is negative 1. Okay, so it moves us around the graphs, these compositions. Okay, now I'd consider those the easy ones. The next two, students have a lot of problems with. Let's take this one. What students fail to do is think about the composition that is involved. And they only think about the square root, and they think the derivative is 1/2 f of x to the negative 1/2. But this is not correct. If you keep the chain rule in your brain, and you keep the O's and the I's, you will not make this mistake. Because yes, the derivative of the roots is 1/2 to the negative 1/2, but I need to multiply by the derivative of f prime. So it is 1/2 f of x to the negative 1/2 like I thought, but times f prime of x. That's what's correct. I have 1/2 root f times f prime. Do it when x is 4. Let's see if this works out nicely. When x is 4, f is 7. So it doesn't work out nicely. Or whatever. I have 1/2 root 7. F prime of 7 is negative 1. So negative 1/2 root 7. Rationalize if you want to. One on the right, g of x cubed. Its derivative is not 3g of x squared. It's 3g of x squared times g prime of x. If you keep your O's and your I's in your mind with this composition, you will not make that mistake. And it's a very common mistake to make. That's just the derivative of g of x cubed. 3g of x squared times g prime of x. Don't forget about the derivative of 2x plus 3. That's just going to be a minus of 2. When x is 4, so 3g of 4 is 3 squared. Fortunately, g prime of 4 is 0, so that makes this problem lame. But oh, minus 2. It's not times negative 2, it's minus 2. Okay, so that's table problems with the chain rule, keeping in mind the O's and the I's. A couple extra problems. Composition like this. What is g prime of 2? G is f of 2x cubed minus 10. What is g prime of 2? So I want to take the derivative of this to get g prime. To take the derivative of this piece, keep your O's and your I's together. The outside is f of, the inside is 2x cubed minus 10. So this is just kind of more kind of table-ish type problems where you're not just given, the function. You're given some f's and g's. So I got g prime of x is equal to f prime of 2x cubed minus 10 times 6x squared. G prime of 2 is what I'm trying to find. Well, that's f prime of, if I plugged in 2, that's 8 times 2, which is 16 minus 10 is 6 times 4 times, okay, that's 24. But now I need f prime of 6. Well, look at what they gave me. They gave it to me at the beginning of the question. I don't have to use it till the end. F prime of 6, I get by plugging minus 12 plus 4. So it's 24 plus 4, 28. I don't want to do these calculations. F prime of 6, 36 minus 24 is 12 plus 4s. Let me just make sure I do this. 36 minus 12 is 24. I was right. So this is 28. So 28 times 24, whatever that ends up being. Next one, similar thing, similar like table type problem. Given h prime is sine x, g of x equals h of 3x. What is h prime of pi over 2? Okay. It should be not h prime, it should be g prime. It's a typo. So taking the derivative of g to get g prime, let's see what I get. Well, keep in mind your O's and your I's. The O is the h of, the I is the 3x. So I need an h prime times 3. I need h prime of 3x times 3. Plugging in pi over 2, I get h prime of 3 pi over 2 times 3. Again, they gave you h prime. Sine of 3 pi over 2 is negative 1, so this is negative 3. Okay, very table-esque in the way that it is asked, where it's not just here's a function, what is its derivative? It's involving g's and h's. You got to look at the other information you're given. Make sure you change it so it's g prime of pi over 2. Last things I want you to be aware of that is very helpful in certain cases is understanding that in certain situations, it's actually advantageous of us to rewrite things so that we don't have a quotient. Like x plus 2 to the negative first. Or, in this situation, I can rewrite this as negative 3 times x plus 4 to the negative second. Especially because inside of the parentheses is just x. I mean, it could be anything else, really. It doesn't matter. But watch, instead of using the quotient rule for both of these, and this would be like a quotient and a chain, I could just use the chain rule. The outside is a negative first power, the inside is x plus 2. The derivative of the inside is just 1. The derivative of the outside negative 1 to the negative second. I can easily, using the chain rule, write the derivative of 1 over x plus 2. Negative 1, x plus 2 to the negative second, times 1. I'm done. This guy, O's and I's. Derivative of the inside is just 1. The derivative outside would be positive 6 to the negative third. I can write the derivative easily using this rewrite method. That's it. All right. Thank you.